Hello, and welcome to this edition of the CSIAC podcast series. This is a multi-part series entitled Fifth Generation Cellular, conducted by CSIAC SMEs Dr. Carl Kucha and Dr. Paul Losowitz. This series will explore a broad range of aspects regarding 5G wireless networks. This episode will discuss new 5G capabilities and applications. This includes mission-critical services, massive Internet of Things, and enhanced mobile broadband. It also explores potential cybersecurity concerns involving 5G technology and methods to mitigate these issues.
So, Carl, as we mentioned earlier, some of the issues will be testing regional differences or international differences in 5G configuration, testing interoperability and vulnerabilities, correct?
That's correct.
Okay.
And not only are we just going to find vulnerabilities and try to fix them, but we have to figure out ways that we can work through vulnerabilities, because it may be owned by foreign systems and they either don't want to or they've got a vested interest not to fix those vulnerabilities.
Okay, so let's transition to discussions about some of those new capabilities that will need to be tested.
Got it. Well, let's give the eye candy chart here first, Paul. There's going to be a lot of really amazing things that 5G is going to bring to us, and one of the biggest that we think is going to be a revolutionary start is what we call enhanced mobile broadband, which is going to allow things like either augmented or virtual reality. The difference between the two, virtual reality, I am shown 100% of everything the computer wants me to see. Augmented reality, which I think is a lot more powerful, I'm actually looking at the real world through glasses that have the capability of displaying information on the glasses that pertains to what I'm looking at. So if I was doing service on an aircraft, I might be able to call up the schematic of the aircraft and have it overlaid with the parts that I'm actually looking at. Or if I'm at a sporting event, maybe I've got stats on a player that are coming up while the player is, shooting hoops or something like that. So there's a lot of really cool things that are going to come out of this technology.
Such as a personal heads-up display for an infantry.
Yeah, that's exactly right, Paul. There's been some science fiction movies that have shown, the spy that has the spy glasses that shows him all the extra stuff he could be, seeing about people when it does facial recognition and brings up all the information about that person. But we are almost there in making this kind of stuff happen.
Outstanding.
Emergency first responders or mission critical services are a huge area. We've already seen the first NAT rollout, which is a 4G system, but it's specifically tailored for the needs of emergency first responders. And this really drives at how do we push 4G and soon 5G communications into areas that are either don't have that capability or the capability was taken away because of some natural disaster or man-made disaster. So we're really looking at how we move those mission critical services around and how they're going to use the 5G system to best do their jobs. Finally, on the right, I talked a little bit about, whether or not 1 million devices per square kilometer was actually something that we had to worry about. And here's a picture of a medium-sized city with a simulation. This isn't just a picture for the fun of it, but this is starting to talk about how many people would have how much data usage in their area. And as you look down that street, you start looking at all those buildings with their sensors and control systems and apartments with all the things they're going to have, that these types of simulations are showing us that there's definitely a need for that level of density. So those kind of things are coming out first.
Okay.
But let's dive into a few other things. And this is one of the charts where I was talking a little bit about that virtual reality. So how is 5G going to make these kinds of things happen? So one of the things is that these devices are going to have computer systems at the end of the edge of the network, right?
Right.
And it's really important that this network edge computing or MEC, multiple edge computing technologies get to be implemented and enhanced by 5G, because we don't have enough bandwidth to push that much video for every user of these glasses through the system. But if the glasses can take care of a lot of the processing, now we have the possibility that we can move enough bandwidth through the system and give the users a fantastic experience without overloading the network. So the latency sensitive, because I don't need to, I look at something else
Right.
and I don't want it to take seconds to get my new picture up. Near real-time operations, thermal efficiency, which is more of an electronics thing, but efficient power usage for the 5G system is also a big thing that we're working on. All of these things are coming together in the 5G ecosystem for the first time. And that's the kind of thing that's going to have the ability to get these applications realized in the 5G system.
So, Carl, could a standalone network, in fact, share the computational load?
Not today, Paul.
Okay.
Even if, and what you'll see with a lot of devices that are like this is that these devices are wired through the network, or they're very simplistic in what they display. So if I have a captive local system with a wired interface, or a captive interface, I can just barely do that. But what we're talking about here is a device that I can walk out into the street untethered, and I can spend my entire day with my battery that's on board my VR glasses with the connectivity that I'm going to need to make this connectivity happen. And that's what 5G is going to allow.
All right, let's go on.
So why don't we talk cybersecurity here for a little bit, Paul, because that's going to be an important element for how 5G is going to be implemented. Um, 4G security, as good as 4G was, there were still a lot of issues with 4G. And just to be clear with everybody, when the new 5G system comes out, when the new 5G system comes out, I said that it was going to be dependent on the 4G core.
Yes.
It means that all of the vulnerabilities from that 4G core are still going to be existing in the first non-standalone 5G system. You can see some of those listed over there on the left-hand side of the chart. Now, the release 15 final version, which is coming out in about a year, we'll probably see it, fix a lot of these issues. And the jump up in cybersecurity protection is excellent. It's really going to be a lot better than it was. The problem is which one of these are turned on and which one of these are turned off. I already talked about that issue. But even with these things, let me show you where there may be a few holes still in the system.
Okay.
So this is a chart that we were allowed to use by Nokia, where the Nokia network engineers took a look at how the 5G ecosystem is going to be implemented, and the fact that data vulnerabilities are going to exist everywhere from the user device, which are all of those elements on the far left-hand side of the screen, all the way through to the cloud on the other end. So whether they're coming through the actual what's called the edge computing piece, or the MEC piece, or they're coming in some of those transport layers, or they're back in the core network, there's still possibilities for either man-made intrusions or hacker intrusions to occur. And we always have to be vigilant, because we don't know what we don't know. And while we always are trying to make sure that everything is cyber secure, it's possible that there's going to be something that's going to come up that we didn't anticipate. One of the things that we do at Idaho National Lab is that we advocate a security policy called CCE, or Consequence-Driven Cyber-Informed Engineering, which is an entire process where we take a look at the worst of the worst of the things that could possibly happen to us, and how we engineer the systems so that even though we may have a intrusion, that intrusion isn't allowed to take a system down to the point where we have a major downgrade or loss of capability. But beyond that, we also should be practicing something called zero trust networking. And zero trust networking is assuming that from the second that data hits the phone, that we should be encrypting that data with strong encryption in ways that other applications on the phone can't get at it. And then what we call encryption at rest and encryption in transport needs to both be used. Once we do those things with strong encryption, or if you want to say NSA type 1 encryption, that's what we're going to need to eventually implement to make sure that our U.S. system stays safe and secure.
Okay, I noticed that they mention attacks from physical access, and we brought up before that for millimeter wave implementations, we're going to be having a lot more end user devices. So that could, in fact, open up a whole new gamut of, let's say, side channel attacks by being able to get access physically, correct?
Oh, absolutely, Paul. The fact that there's so many devices that are going to be out there with 5G portals, how we secure our networks is going to be very important. And this isn't just from a device standpoint, but this is going to go back to how our subnets are secured from each other within our own home or small business or base network
Okay.
systems. The other thing that's really interesting is that if you are working with these very, very small cells, and each one of these cells, by the way, is going to be registered geographically, just by knowing what cell you're in, will be able to geolocate you within, say, a given house, which is a possible security vulnerability if you're trying to make sure that nobody knows where you are at any one given time.
Right, right. Okay.
So,
Well, let's go on, Carl.
great. So let's take a look at some of the devices that are out there from the 4G to the 5G ecosystem, because there's one other thing that I'd like to discuss on how these new systems are coming out. In the past, with the 1G, 2G, 3G, and 4G systems, they were very specific to one vendor. And the three major vendors in the world are Nokia, Ericsson, and Huawei. And each of these vendors would create a system that was very specialized. It was their box, their interfaces, their card cages, and you couldn't just go out and buy any kind of equipment and just slide it in there. You were stuck with that one vendor. And that one vendor usually was doing a pretty good job with cybersecurity, although we can argue that Huawei is possibly needs a little more evaluation and help. But in general, how those systems were integrated was very, very tight. But let's go on to what the future actually holds. The actual equipment that was in those things wasn't anything particularly special. They were just big computers. So things like HP servers, server racks, and Cisco routers were the core components of what made up all of these computer systems. And what we're starting to do is to move away from a single vendor specific system to what we call network function virtualization.
Okay.
Or a variety of vendors that all could be supplying equipment that are all generic. And every one of these systems, you can plug in the generic module, you load your generic software. They've all got interfaces that have all been agreed upon and standardized, so that what you see is a system that looks a lot more like this rather than that one big gray box that was existing before. So in the bottom of that chart, you see that there's a whole series of hardware devices that are all ubiquitous. They all might be blade servers, or they're all going to be the kinds of things that I can move software around in between systems. The only time you're going to have an issue with a specific piece of equipment is when you get to the very end, when you've got that radio up converter that's going to put the signal up into the antennas. That'll be a unique piece of equipment. But everything else all the way back through the system, the routers, the computers, all the processors are all ubiquitous.
So the virtualized wireless network, the logical network is the new paradigm for the future as opposed to a hardware implementation.
It is, absolutely, Paul. And there's a lot of really great things about this. We saw the exact same thing happen, by the way, with PCs. Back 40 years ago, when everybody was buying mainframe computers, you bought IBM. You didn't buy a different kind of a disk pack, and you didn't buy a different kind of an internet interface card or a different kind of a terminal. It was all IBM stuff. Well, you look at it today, and there's companies that have arisen that said, I'm Western Digital, and I'm going to build the best disk pack that anybody's ever seen. Even going forward now, I'm going to build the best solid state drive anybody's seen. And those innovations with a single company, with a single drive, have made innovation in the computer space very, very agile. We're just about to start this in the cellular. And the 5G world is going to be the first one that's going to really bring this to bear. Keep in mind, with so many people out there, that we've got potential vulnerability and compatibility issues that we're going to need evaluation and testing for. But this is where we're going. It's a great thing. I highly recommend it. I highly recommend it. But I think it's going to be a great thing for the industry. But there's a couple of things that are going to make this really cool. The next one is that virtualization software level. And that level monitors all of the hardware resources and how they're doing as far as their load and how much information is passing through them. Maybe they've got maintenance issues. They're starting to slow down for other things. Maybe they've been broken in some way. And it has the ability to take those software packages, which is the next level up, and it can reallocate those amongst all of those different hardware packages. And that's why we call it network function virtualization, because this is all virtual. I can move it to anywhere. So these software packages already have proven the ability to detect maintenance issues with blade servers and automatically pull the software off of those blade servers and reassign it to another server, and then flag that server for maintenance, and there's no interruption in throughput or service to the users or customers. So this is a great thing. There's a whole new series of companies that are building all of the software codes that are going above that. And I'm not going to drive into all of those. Above those is where the human intention is allowed to be injected, or this is the HMI interface layer, where you put your policies into the system and you show, how you want your resources more or less allocated within the system. Now, for those of you that are software-defined networking fanatics, this is software networking applied to 5G connectivity.
Okay.
Why that's important is that the 5G system is not a pure 5G system all by itself. It's interwoven with the internet fabric that controls the rest of the internet and all of that software-defined networking that now is getting rolled out there. So when we are talking about testing a 5G system, we also have to test how that 5G system interrelates and is controlled by the 5G, the internet fabric that is what we call the internet. So the line between last mile wireless communications and internet now has been blurred because the two of them share functionality.
Okay. Let's go on.
Sure. I just put a word about security in for the far right-hand side. Security has to be ubiquitous across everything. We're not quite there yet. Today, security really is a bespoke operation because each one of these has got a little different security issue. They've all got their unique characteristics. So the guy that has to handle security nowadays has got to literally be a cellular network engineer that's been trained on IT security. 10 years from now, maybe, when all of this is really standardized and we've got better integration of how these all work and the security system is better, then we'll be able to have the network security professional that is a really hot shot.
So currently, you're saying that we have a dire shortage of people with the technical expertise to do an end-to-end security evaluation
We do. We
of,
do.
of an implementation.
Right. Now I know there's some groups in the military that are starting to build up their security infrastructure to do
Mhm.
some of this. Idaho National Lab, we've been working on this type of security with our research groups, so we've got that kind of security. But this is not something that you can just take your off-the-shelf IT security guy, sit him down in front of that security box and say, make my system secure. It's
So,
coming, but it's not here
so
yet.
the development of TTPs is going to require access to these subject matter experts who have that end-to-end knowledge, correct?
Absolutely agree with that, Paul.
Okay. Important to remember. Thanks.
Thanks.
On behalf of the CSIAC, we would like to thank you for viewing this podcast. We hope you found the content informative and useful. If you would like to provide feedback or comments, please visit our website at www.csiac.org, where you can also find additional content to review. Thank you.
Did you know that CSIAC offers free monthly webinars featuring experts in the areas of cybersecurity, software engineering, modeling and simulation, and knowledge management? Come see leading industry professionals talk about industry practices and leading research. Make sure to visit www.csiac.org/webinars in order to subscribe to our mailing list and see when the next webinar series is available. There you can also watch previous webinar series to catch up. Visit www.csiac.org/webinars.